Hello. This time we're going to address the question of how many non-negative integer solutions are there to this equation with 5 variables, and where for each of the variables it has to be assigned a number less than or equal than 2. Uh, we can think of this as we don't get more than 2 for any of the items associated there. Okay, so I think we can solve it using the principle of exclusion inclusion. The pi. Right? And how is that we're going to do it? Well, let's see. Probably we need to make a description because we says no variable gets more than 2, a number more than 2 as assigned to be assigned. So let me write it as none gets more than 2. Okay, none, I refer to the variables, right? No variable gets assigned a number greater than 2. So how can we decompose it? Well, we can think in these terms. The number of such items, right? The number of ways in which we can do that can be described in this fashion. I can say, well, let me count them all, right? Let's count all distribution. That's what we're doing here. But then I have to make a subtraction because I have to take away those for which, well, there's some assignment of 3 or more. But I can do it in stages. I can say, well, I'm going to take away those assignments for which one of the variables, at least one of the variables, got 3 or more. But then you say, well, you're over discounting. You have to put back those cases where at least 2 of the variables gets 3 or more. And well, then we have to keep on going, right? By simply saying, well, now subtract where in the case where 3 of the vars gets 3 or more. Well, then you may wonder, where is that we have to stop? I think we have to stop here because we cannot progress anymore. We cannot say, well, 4 of the variables get 3 or more, because if 4 of the variables get 3 or more, then the sum of those variables would be 12 at least. Well, that means that we should stop here. Okay, now let's get the full description of this, and well, let's build it. All distributions. Well, to get all distributions, that's fairly simple. This is a stars and bars problem. Nothing more than that. Say, okay, I have 10 things, right? Those are my stars, and I have 4 bars to distinguish the 5 objects that I have here, the variables. So it would be something along these lines. It would be 10 plus 5 minus 1 shoes, right? 5 minus 1. That corresponds to this part. Now, for this one, it would say subtract. Well, it says one of the variables gets 3 or more. Well, I'm going to decompose it using the multiplication principle by doing this in stages. The first thing that I'm going to do is to select one of those variables to assign 3. And I'm going to say it explicitly. So that would be from those 5 that we have here in terms of variables, I'm going to choose 3. And saying, here is where you say 1 gets 3. But then you have to distribute the rest, and that corresponds to the at least part, right? At least, at least, at least. Okay? How much is left? Well, I have 7 things to distribute now among the 5 things that I have, right? And I'll do it in this fashion, 7 plus 5 minus 1, choose 5 minus 1. Then, to produce this one, right, it says, okay, again, in 2 stages, I'm going to say 5 choose 2. In other words, pick 2 variables to assign 3 to each, and then you distribute the rest in whichever way that you want. Okay, but now, well, we have this. This would be from 4 that is remaining from the distribution. You have to distribute them among 5. 5 minus 1, 5 minus 1. And lastly, right, we subtract, and we're getting the idea. From 5, we choose 3 to assign 3 to each. And then we distribute the 1 that is remaining among the 5 that we have there. So 1 plus 5 minus 1, 5 minus 1. Then, of course, this reduces a little bit. This would be 14 choose 4 minus 5 choose 1. This would be 4 plus 7, and that would be 11 choose 4 plus 5 choose 2 times, well, that would be 4 plus 4, so that is 8 choose 4 minus 5 3 times, well, that one would be 1 plus 4, so 5 choose 4. And it turns out to be that after just careful computations, this is 1. But this is not a surprise. Why? Well, look at the requirement. We're saying that none of the variables can get more than 2. Well, we have 5 of them. There's only one way of doing this. Assign to each of those 2. Well, this is a very surprising way of, or a very complicated way of obtaining 1. So if you ever wonder how to write 1 as in a fancy notation, well, you may use this one if you wish, right? Or present it as this particular problem. Okay, so see you next time and take care.